Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
I'm your co-host, Rich Gear, and we are glad to have you folks with us. We have a subject that's been in the news recently in the last several years, the planet Pluto, or is it a planet, Doug?
Well, it's something that they're trying to figure out if it really is a planet or not.
I know.
And recently we've had the benefit of NASA using our tax dollars to send probes out to a lot of the different planets in the solar system.
Of which, by the way, I am not against that. I'm kind of glad figuring out stuff, because over the years, Doug, and you brought this up, and we've been reading articles, a lot of stuff is really helping confirm more of the creationist worldview rather than the long old universe scenario. So,
oh yeah, the different probes that they're sending out are the friends of creation.
Once again, you know.
And so, if you go out and gather scientific evidence, it doesn't. If you have the proper perspective on what that evidence is, you can interpret it in a way that if you have a biblical worldview, it actually helps us quite a bit. And the surface is young, according to this article that Danny Faulkner wrote, and actually Answers in Genesis, I think, published this article.
This one? Okay.
And what he says is that they were expecting, if Pluto is 4.5 billion years old, that Pluto would be heavily cratered.
Now,
and
Doug,
they find that as a general rule with many of the different bodies in the solar system. But
let me ask you this question: based on the uniformitarian or old universe scenario, would Pluto have been formed first or would the inner planets be formed first? How does that work? Do you know?
Well, they would have probably thought that the whole solar system would have been formed in one event.
Probably basically all at the same time. I was wondering, because you're 4.5 billion years old for the age of Pluto, and that's what they postulate 4.6 billion for the age of the Earth. So I'm going, that's 100 million years.
Now, it's interesting that Pluto's orbit is a little bit tilted in comparison with the rest of the solar system.
Okay.
And that makes it a little bit of an anomaly. And so one, I suppose, could argue that Pluto was a captured body rather than one that was actually formed at the same time as the rest of the solar system. So I suppose they might get away with that, and they might also say that because it's on that tilted angle, that there would be less of the likelihood of it encountering objects that were formed at the time of the solar system.
Oh, okay. There had to be some way. These guys always figure out some way to just basically after the fact ad hoc explanations.
So
they
there
have to
you
come
go.
up with something.
We're giving it to you as
we're giving you an ad hoc explanation for why you are not seeing what you predicted as what usually happens with evolutionary or long-age scenarios.
No.
All right, so Doug, what are some of the things that were predicted in Pluto they should see that they're not seeing?
Well, here's what they actually didn't. They predicted that there wouldn't be a magnetic field, so they didn't bother put any instrumentation on the New Horizons spacecraft to detect it.
Once again, your beliefs determine what you will see. So they didn't bother bringing the equipment. So we don't know.
They expected the planet Pluto to be an icy body,
right?
And they wouldn't have a rocky core. Well, that's something that they've shown to be not true. That
it has a rocky center.
Core.
Yep.
And so and its moon Charon, they're sort of like similar bodies. They sort of orbit around each other, actually orbit around the common locus of an ellipse.
Okay.
So that...
well, are they two moons? Are they two planets?
Well, they're like a double planet in actuality, where one's a bit bigger than the other. Pluto is bigger than Charon. But
now, how is it we were able to see, Pluto was discovered in 1930?
Yes.
Around thereabouts? How was Charon not discovered? When was that discovered? I mean,
well, it wasn't until the telescopes were able to resolve the binary nature of it.
Okay, so we've got a planet that became not a planet, and then now it becomes a dwarf planet. Now it might be a double planet. I mean, what?
Right.
This is quite a wild,
And actually,
wild
there's
ride.
3 other moons. There's Nix and Styx and Kerberos.
Okay.
It's interesting. Kerberos is a computer security technology.
How do you spell that?
Kerberos.
Wow. Okay. All
And I
right.
think it's one of these Greek or Roman gods. Or
And first
something.
time when you said that, I thought you said it was Charybdis, which is another Greek, legend. But anyway, so we've got 5 objects. Well, one of them is actually equivalent virtually to Pluto in the sense they're revolving around each other. But where do the other 3 moons or 4? Where do they rotate
So
around?
they rotate around the 2 of them.
They all rotate around both.
Yeah,
Oh, is that
they're,
right?
They're all orbiting in their own little goofy orbits. So
So, Doug, we have a rocky core, which they thought it would be an ice ball. We have not 1 moon, not 2, not 3. We have 4, although one of them might be a second planet as opposed to a moon. That to me qualifies as a planet to me. But the other thing you were talking about, we were reading in this article, is there's the amount of cratering on Pluto is very, very little, right?
yeah, there's very little in the way of cratering on either Pluto or Charon.
Okay.
And that is a shock and a surprise to the evolutionists because they would expect, after billions of years of time, that there would have been many collisions, especially since Pluto is in the Kuiper belt. It's a part of the solar system that where you have a lot of little planetoid type of objects out there. And they theorize that the Kuiper belt is the origin of a lot of the comets, as well short period comets. And the long period comets, they believe, come from what they call the Oort cloud.
Which is,
And,
which we have no evidence for that at this point, right? Or do we?
We can't see out that far.
Yeah, okay.
And so that is a curiosity that they're trying to figure out. But this whole idea that they didn't, it's a disappointment to us that they didn't bring along enough, the instruments to measure the magnetic field, because we would have predicted that there would be a magnetic field. Dr. Humphreys has shown that the planets have a magnetic field that is consistent with what they predict would have been based upon the mass of the objects and the age of like 6,000 years for the age of those planets, based upon the decay rate of the magnetic field.
Right, because here on Earth, they propose what's called the Dynamo Effect, because the reality is our magnetic field is we really shouldn't have a magnetic field, at all, because if our planet is 4.6 billion years old, it should have gone down to nothing based on rates of decay. You talk about Barnes. Barnes kind of brought that up, right?
Yeah, Dr. Thomas Barnes first came up with this theory back in the 1960s.
Yeah.
And he published a paper called The Decay of the Earth's Magnetic Field, and he extrapolated back, based upon the measurements of this decay, of what it would have been 10,000 years ago, and the magnetic field of the Earth would have been enough to be that of a magnetic star.
We'd be equivalent of a star 10,000 years ago. So what happens is that they postulated, once again, something that we have no evidence for, but they have no choice to but they have to come up with an after the fact and ad hoc, the dynamo theory, which basically it winds down and then recharges, goes down, goes up for billions, hundreds and thousands of times it must have done that. But we have no evidence for this recharging itself yet. How would you even get that?
Yeah, Dr. Humphreys has altered to this magnetic theory based upon reversals. Because, so there is evidence that there was reversals of the magnetic field, but it's still something that was stronger in the past. Yeah. And now is decaying quite a bit. So we're losing the magnetic field around the Earth.
Right. Now the thing about it is, that being the case, if the decay is good, now even with reversals, Doug, you should have virtually no magnetic field. And Humphreys predicted, it's interesting because when these probes are first going out to the outer part of the galaxy, you know, our outer part of our solar system, I mean, and they predicted really virtually no magnetic fields in the Neptunes and Jupiters, and there'd be virtually nothing out there. But Humphreys predicted there would not only would be, but his estimates were thousands of times greater than the NASA scientists and the long universe people. His predictions came kind of really right in the middle of the parameters.
He had the data that at that time they had the data out to Saturn. We had the data for Mars, Jupiter, and Saturn, and they didn't have Mercury yet, because they hadn't sent the probe to Mercury. They had it for Venus, and when they sent the Voyager spacecraft out, that's when they not only they got for Saturn, then Uranus and Neptune. And Humphreys had predicted what that value would be for both of those planets. Right. And he was right on with his prediction.
But again, if his predictions were the same as the long-ager ones, which there's no way they could possibly be, but just say, okay, then that wouldn't be such a big deal. But or they were close. His predictions were way larger, than the NASA scientists, and yet his were right as a young universe guy, as opposed to the NASA's, which are an old universe person. Now Pluto once again seems to show or belie the fact of the old universe, based on the fact not only is there little cratering, but there's not a lot of volcanism to cause some of these craters to get eroded off. Like some of the moons, of Jupiter, Io, and was it Ganymede? Which is the one that they had? There's evidence of volcanism. And so you can see craters can be eliminated because you have a plastic surface that's just changing. The dynamics of the surface can change over time. But Pluto's a dead, cold planet.
At least so they think.
Yeah, at least so they think.
Here's a problem: is that Pluto has a nitrogen atmosphere, and so they would have. The prediction would be that it wouldn't have an atmosphere. And so there's something that's outgassing from the planet, which means that it's not. It still maybe have some life down deep within the core of it.
Now, when we say life, we're not talking about organic life. We're
talking about heat.
Heat. Okay. Yeah.
And so there's and so they would predict that if there was any heat that's coming from this, it has to come from a radioactive source. Well, if that radioactive source is decaying for any period of time, it would have long lost its decay if it was old.
Okay.
And so they have to understand that Pluto is young based upon many different factors.
Well, let me ask you, just play devil's advocate here. We have decay rates here on Earth. We have a planet that's approximately the same age as Pluto, and we still have decay being measured. So why would that prevent Pluto from having decay that can be measured? You know what I'm saying? In other words, what they have uranium, lead. I'm just throwing that out there, or potassium, argon, or rubidium, strontium, or something.
Well, we're talking enough to cause some heat down in the core. And because Pluto is such a small object, it would
that's the point.
lose it a whole lot more rapidly.
Right. Okay.
And so, and not only Pluto doesn't show enough cratering, neither does its companion Charon. Charon is relatively devoid of cratering, and there are a lot of mountains on Pluto. 11,000-foot mountains on Pluto, and so you would tend to think that there would be enough activity.
Are these mountains made out of ice or made out of rock?
Rock.
That is, to me, amazing. 11,000-foot mountains on Pluto. You know, it's interesting. This is a real sidebar, but my son sent me a YouTube video the other day. We were kidding about life on the planet, and the guy who did the YouTube video is actually pretty fair when he was kind of saying, "Boy, there's weird structures on Mars. I'd like to know a little bit more about those structures, but they're very rectangular and like he's saying, well, what are they? Are they cities? You know, remnants of lost, dead cities." I tend to put that in the category of the Mars face and the Mars canals. You know, that they remember how H.G. Wells wrote a big science fiction story because of the channels, you know, the canals. I'm sorry, not channels, but canals on Mars. And this kind of, I would put that in the same boat. That's when you said there's life on the planet. I went, huh, what? You know, there's a YouTube video. It's pretty interesting. I don't disparage it because the guy was pretty fair in this video. He wasn't saying anything, but he's a real cool looking structure. That planet is turning out to be a lot more interesting than anyone would have thought.
Yeah,
you know?
It definitely is, and it sort of reminds me of when the Galileo spacecraft visited Io and Ganymede around Jupiter, that they were finding all these fascinating structures that they, you know, the Ganymede has a lot of these faults, and it looks like the whole surface of it's cracked.
Yeah.
And Callisto and Europa apparently has a surface they think was actually might have had water on it. So.
Oh yeah, yeah.
And so they keep looking for life in outer space.
Now, I want to throw this out. To me, water is not a cause for celebration for an evolutionist. In a sense, Humphreys kind of postulates everything, if the biblical story is correct, everything was made out of water anyway. So why would we be surprised there might be some H2O, either in ice or, you know, they're trying to find liquid. But Doug, that we know in our planet, without water, life cannot exist.
Right.
But we also know that water is a corrosive, and it prevents any life from organically forming, you know, from compounds or, you know, from matter. It doesn't help anything if you have water. That's why oftentimes they postulate on our planet the reducing atmosphere, which has been kind of debunked in recent years anyway, because
oxygen and
oxygen and water are just corrosives, you know.
Well, the problem is that in order to create the peptide bond, that you have to remove water to do that, and you have a COOH and an NH. 2 that is part of the and you remove the HOH, which is the water, and they bind together that way. But and so
here's the chemistry professor talking right now. So pay attention.
Is an enemy of the peptide bond.
Water is the enemy
because it's reversible, and you would have to. Somehow
it's the old adage, which came first, the chicken or the egg. If everything has to work for anything to work,
right?
And water by itself does not really have a reason for evolutionary things to happen, but yet they're caught between the rock and the hard place, no pun intended again. But you need water for life to exist, at least as we know it. But yet it's the very thing that prevents life from coming to pass. You know, that's why when Miller-Urey did his experiments, he had kind of sucked off the little amino acids off to the side, because if they went back into the primordial soup, they'd die. The water would kill it. But anyway, that's a sidebar. So Doug, there's no volcanism, got a rocky core, yet 11,000-foot mountains, no cratering.
Right, and so
how does this help you long agers? You know, how does this help you out there?
What I also find fascinating is the search for intelligent life in outer space.
Well, that's what.
And the question is, if you can't detect it here on Earth, you say that there's no intelligent design here, but you have all these criteria that you're using to determine if something's intelligently designed in outer space.
Right. It's the same criteria we would use that we would use as creationists. That, you know, there's certain things you can indicate that there will be signs of intelligence. You can tell things that are natural processes. Yeah, you might find a side of a mountain that looks like Chief Crazy Horse or something, but the carving out there in South Dakota is obviously a work that someone's planned and thought out. It's not natural erosion. Same thing, or the Mount Rushmore figures. You know, you can tell that's a lot different than just something you can kind of, like a cloud formation. You can see sort of a thing in there, and the ideas of repetition and pattern, and organization, and ability to replicate all those things. Look, Doug, we look for intelligence. We would look for the same things. Yet out there, it works, but here, the DNA molecule is no sign of intelligence. It randomly happened, you know, or
a
by
little
chance.
bit about Dr. D. Russell Humphreys. He's a physicist, and he was with Sandy Head National Laboratories. And
well, he was there. I don't think he's there anymore.
He's not there anymore.
Yeah, he's retired from there now. Yeah.
But a little bit about the history of all this is, first of all, Thomas Barnes did the description of the magnetic decay theory.
Thomas K. Barnes, right? Isn't that his middle initial?
Thomas G. Barnes.
Is it G? Oh, I'm sorry, G. Yeah, right. Yeah.
And he was at the University of Texas El Paso for many years.
Okay.
But Dr. Humphreys took that theory, and this is based upon a free fall magnetic decay of the Earth's magnetic field.
Okay.
And he predicted that if there was a decay of the magnetic field based upon what he measured, that you couldn't have it more than 10,000 years old. And so that was the beginning of it. Then Dr. Humphreys he came out with an article, I think in 1978, that talked about the decay of the Earth's magnetic field, but he...
God, was it that long? It was that long ago? 78, you said?
78 was when he was first starting to speculate about this.
Okay.
Then he came out with his article based upon, it was after the Voyager spacecraft started gathering all this stuff about Jupiter and Saturn.
Right.
And I believe it's early 80s when that occurred, that he said, well, we've measured the magnetic fields of the planets already for between Jupiter and Saturn, and I think Mars also had and Venus had been measured.
Right.
And it fit within his theories because he says that based upon the mass of these bodies and the prediction that at the beginning there was the maximum polarity of the magnetic field would have been there.
So from these he extrapolated for the outer planets. Is that what he did?
He extrapolated it for Neptune and for Uranus.
Yeah. Okay.
And so those when they because of those predictions, those magnetic fields, when the probes went out to Uranus and Neptune, they also confirmed Dr. Humphreys' theory. Yeah,
that except in creationist circles, you never hear much about that. But boy, I tell you, I read that, especially when you try to find out how different the predictions were of the NASA scientists compared to his. And I'm surprised more heads weren't kind of shaken. But at least, Doug, they did. Amazingly enough, they did bring magnetic or things to measure the magnetic field.
They would have predicted that there would have been some measurable,
because of the size of the planet.
Right.
But Pluto, there should be nothing out there, so that's why they never brought anything.
Then when the Galileo probe went to Jupiter, and they investigated all the moons of Jupiter, I was the one who talked to Russell Humphreys and said, how do the moons of Jupiter fit?
Right.
And he did some back-of-the-envelope calculations. He says, they work too.
Wow. Yeah, I remember you doing that.
And so that was really cool when and we had a chance to interview him out in Albuquerque.
Yeah, that was fun.
And we also had a chance to interview him at Gull Lake at one time. And,
Yep.
and that was the time, 2/3 of the way through our interview, there's some
Some knucklehead tractor rider decided to go right through the thing. Wrecked that interview.
Up his lawnmower
Yep.
and wrecked our interview, but
It was good up till then, though. But
it was pretty good.
well, Pluto's turned out to be a very fascinating, whatever it is, planet, dwarf planet, double planet. You know,
Right.
I can't wait to continue what is going to continue on right now. How far do you know this probe that going on? It just keeps going out, right? Isn't it just going to keep going out?
Yeah, they'll probably try to measure, see if there's anything else out in the that area, the Kuiper Belt. But so far, and actually, there's dozens of bodies that they've found out there already now.
Yeah.
And I think there's actually one that's bigger than Pluto itself.
Is it really?
Yeah.
Now is that like another planet, or is that something totally another ice?
That's
We don't know
another
yet.
planetoid,
That's
yeah.
another thing, right? Yeah. That's awesome. Well, it's fascinating, Doug, because I mean, this is kind of this weird body out there that you're not sure what it is, but it's really kind of, well, I mean, you're not hearing anything that's any waves of consternation going up in these long agers, but I'm saying they should be a little bit worried.
They're
you
talking
know?
about it. They say this thing looks young,
Yeah.
and even they admit it.
Yeah, that's kind of amazing that they would admit that. Well, there are, like I say, there are people, you know, even with their own biases, prejudices, whatnot, will be truthful when they see the evidence out there. But it's just too bad, Doug, that some of the things, it would have been nice to see what the magnetic field, if there was any out there. I would have loved to have seen that. Is there any other probes, you know, that are going out there that neck of the woods?
Well, I don't know if they're going to pony up the money for that.
Yeah, I know. That's true.
We'll see you next time on Revolution Against Evolution.
Bye-bye.